Welcome everyone to this video. Uh, we have question regarding kinetic theory of gases um, in this one. So let's see. So it's a rather interesting question. We have a manometer which is in shape of a unequal length pair of tubes which are connected via horizontal tube. Now via stopcock we can introduce mercury inside these tubes, and the mercury will enter these tubes because of the effect of vacuum. So earlier, though vacuum is not there, instead we have 80 centimeter of some air is there whose pressure is 80 centimeter of mercury. This is the pressure of air. Now mercury is waiting to enter this particular portion, and we open this particular uh, stopcock. After opening, we notice that the mercury has entered up till a height of say 10 centimeter, of actually 10 centimeter in this particular column, and in a unknown length in the other column. In the other column it has entered by some unknown length. This length is L naught. It is also given that the height of the column on the left, that is the whole tube on the left, is 50 centimeter, and the height of the column on the right is 100 centimeter. Both the columns have same cross section area, which is 1 centimeter square. Our objective is to find what is L naught. Uh, so let's begin. So basically, first of all, we'll assume what kind of process is taking place, which is happening with the air present inside the uh, manometer tubes. So the process which is going inside is isothermal process. That means initially we have air, 80 centimeter of mercury air is there. When the mercury is introduced, that mercury pushes the air against itself, and it increases its pressure until the pressure of the mercury and pressure of air is balanced. So initially we say the pressure into volume of the air is some constant. So we say that this is an isothermal process. So that isothermal process is what we'll say we can apply on both the members of this manometer. So let's see. So first of all, this pressure which we initially have is 80 centimeter of mercury. It would be multiplied with the volume, which is 50. Now finally, let's say the pressure inside the mercury column is some P1. The volume length is only 40 centimeter. So from this we can find the value of P1. P1 would be some 50 by 40 into 80. That would be 100 centimeter of mercury. Uh, then, what about the column on the right? Column on the right also we have 80 centimeter of mercury of air, and it is occupying initially 100 centimeter of volume. Finally, the pressure reduces to P2, and it is occupying only 100 minus L naught volume. If we multiplied area over here, that area will simply get cancelled out both in LHS and RHS. That's why we are omitting the area A equal to 1 centimeter square. So this is the other equation which we have, right? So next, we'll apply P plus rho GH, that is whatever pressure is above the mercury column plus the pressure of the mercury. So in the left column of the manometer, the pressure is P1. So P1 plus some 10 centimeter, that is the pressure. In the right column, the pressure is some P2. So P2 plus some L naught, that is the pressure. So this implies P1. P1 we already know that is 100. So 100 plus 10 minus L naught is equal to P2. And this implies 110 minus L naught is equal to P2. We'll substitute this value in this equation over here where P2 is already there. So this becomes 8000 is equal to 110 minus L naught into 100 minus L naught. So this equation becomes 0 is equal to 3000 minus 210 L naught plus L naught square. So this is a quadratic equation whose roots we already know. It will have both the roots as positive. One value will be much more than 100, other value is less than 100. So that would be what is acceptable for us. That second value is some 15.49. So we'll approximate as 15.5 centimeter. So that's it. That was this question. I'll summarize this once again. Basically, we have a U2 manometer. On the left hand side, we have uh, co- uh, a, a tube of 50 centimeter length. On the right side, we have a tube of 100 centimeter length, which causes mercury to rise unequally in both the arms. So using length of one of the arm which we have measured, we are supposed to determine what would be the length in the other arm. So we use isothermal process. We say whatever air is present inside this column, that would be compressed isothermally. So using that, we have figured out, okay, what would be the length. Its value is some 15.5. So thank you for joining and have a good day.